Next, let's go to page 769, where we look at how to solve systems of equations by inverse matrices. First, let's consider how we solve a regular equation. Like if you have a simple equation like this one, ax equal to b, where a and b are numbers, like say a is 2 and b is 3, or b is 4. Let's say a is 2 and b is, I don't know, let's say b is 8. A is 2 and b is 8. Okay, how would you solve this? The way you do it is you multiply each side by 1 over a, which is also written as a inverse. If you do that, a times 1 over a will become 1. Okay, and the other side, the 1 over a will be multiplied by b, and that your x end up being a 1 over a times b. Now the same style or pattern, let's say, applies to matrices as well, and that is how we're going to solve the equation. That is, let's say we have a times x equal to b, where a, b are regular number matrices, and x is the variable. Okay, the way we do it is we take a, the inverse of a times a, which will give us 1. Okay, on the other hand, on the other side, we take a's inverse times b, and following the same pattern as above, what we have here is then a inverse times a is 1. The identity matrix multiplying anything is just itself, and out of that we managed to solve x equal to a inverse times b. Now that is better explained from an example. Let's turn to the next page, page 770. Let's look at example 7, where we solve a simple system of equations. Well, relatively simple, I guess. Two variables, two unknowns, and we're going to do what we just said, and pull the inverse matrix in order to solve this thing. So first, let me write it down. Now, in example 7, we have some equations here, right? And we're going to write it in matrix form, so that the matrix A represents the coefficients 3, 8, 4, 11. X, now pay attention to the X, okay? This is big X, this is small x, so they're not to be confused. Big X is the variable matrix. The variable matrix consists of two things coming down, X and Y, all right? And then B is this the two-thing matrix, which only has 5 and 7 in it. All right, so what is AX times B? What we're going to do is doing matrix multiplication. Matrix multiplication, AX times B means you take the first row times the first and only column, okay? So you take this times this, that would be equal to 3, let's see, yes, 3x plus 8y, okay? I'm doing matrix multiplication. So AX equal to B, AX equals to this thing. I'm writing it down, okay? This is A times X. Let's see, AX. This is equal to this. Yeah, I think my marker, I'm not holding it right. All right, so this is the first row times the first column. The second row times second column is 4x plus 11y. So as a result, as you can see, this is exactly that part. So AX is this thing, okay? And then that equals to B. B is exactly this, 5, 7. All right. I will change marker. And so as you can see, this is where the equation AX equal to B come from. And so what we're going to do is find the inverse of A and then multiply it with B, and to do what we just showed you. That is this trick in the previous page. I'll show it to you again. We're going to do this thing right here. See, we have AX equal to B, which is written like this. This is the same thing as that. Okay, it's just written differently. So that is AX equal to B. We're going to find A inverse of X and then multiply with B. That will give us X. That's the plan. Okay, so let's do that. first we are going to do is find A inverse. Now, A inverse has a formula that we mentioned earlier. Okay, the formula is right here in the example. So please look at it again. Here's the formula. You don't really have to memorize this, I don't think. Anyway, but right now we'll stare at this formula, which will give us the inverse right away. So A inverse equal to, I'll write it right here, equal to, according to this, first 1 over, that's AD minus BC, okay, doing the x cross thing. So multiply this way, subtract by multiplying back up. Well, anyway, so that would be 3 times 11, that's 33, minus 4 times 8, that's 32. Wow, how lucky. So this thing is just 1. All right. And so next we have, we'll write this thing down like it says, follow the formula in the book, okay, which says D minus B. D is what? Let's see. I think it goes A, B, C, D. Okay, so D is 11. D is 11. And then B, minus B is negative 8, minus 8. Minus C, A, B, C. C is 4, minus C is minus 4. And finally, A is 3. All right. So we have that. And that is just this thing, because that is 1. So that equals to 1, so we can ignore it. So that's A inverse, okay? Because this thing here is A. That I was doing A inverse. And so then, okay, so we found out what A inverse is, and we're going to multiply A inverse by B. That is A inverse times B equal to X, okay? So because that is what the formula says in the previous page, which we will look at it again. Okay, here's on the previous page. See, it says X equals to A inverse times B, and that's what we're going to do. So let's do that. What is A inverse times B? That would be equal to, I'll write down A inverse right here. That's just 1, so we can write down minus 1, 11, minus 4, and 3. And B equal to that thing right here, okay, 5 and 7 times 5, 7. Okay, and so now to multiply this thing, we're going to do row times column, okay, one at a time. That equals to, that is 11 times 5, 11 times 5, 11 times 5, let's see, minus 8 times 7. Minus 8 times 7 times, all right, that's the first number. We'll figure that out in a little bit. Second, this times that, okay, row times column, that gives us minus 4 times 5, that's minus 20, and then 3 times 7 is plus 21. Okay, so that equals to whatever that equals to. Well, we better figure out what that equals to. Let me see. The bottom is 1, right? Minus 20 plus 21. That's 55 minus 56. That is actually just minus 1. So that is equal to X. And so what does that mean? Remember what X is. X is XY, okay? That is big X equal to small xy. Why do they use so many x's? Well, in math, it's just people do that. You just have to bear in mind the big X and the small x are completely different things. The big X is a matrix, the small x is a number. And so anyway, this lines up, what that means is that this x equals to minus 1 and this y equals to 1. And that's our solution from the very beginning. So x equals to minus 1, y equals to 1 is our answer if I didn't mess up. I should check to see if this is right. Okay, let's see, what did they say? Minus 1, 1, yay, I am right. So that is how this new trick is doing. Is we will find the inverse of the matrix, and then we multiply it to the inverse of the matrix that's formed here will be multiplied to this thing, okay? In that order, by the way, inverse times this, and that will give us the answer. If you can find the inverse. Remember, if this number on the bottom ends up being 0, there is no inverse and you can't find nothing. So there is nothing to find. In that case, either there's no solution or is indeterminate anyway. It's a mess. There's no point in looking at it, basically. So we mostly just deal with cases where this number down here is not 0. And okay, so that is example 7. All right, so next let's do problem 7. Problem 8. Problem 8 on the page 771. Problem 8 is exactly the same as problem 7, except more tedious. Okay, now we have a 3 by 3, 3 equations, 3 unknowns, and guess what that means? That means we have to find the inverse of a 3 by 3 matrix, which looks like a real pain. Why do they have such a big number? Anyway, so we're stuck with doing that, so let's make the best of a bad situation. All right, and so we have this particular matrix. The matrix is just written down all the coefficients, see, and they're all the same. If you see anything not the same, that's because I messed up. It should be all the same. Anyway, so this is the last row of stuff. Okay, all identical. Now the first job. Oh no, I forgot to write down the x, y, z in here. Let me do that. So as a result, we have I got the x, y, z written down. So what happens? You take the row here, multiply by x, y, z. You get the first equation, just this part, and that will be equal to the first number, and so on. See, that is so. In other words, this is just another way of saying this. These two things say exactly the same thing, but this is saying it in matrix form. So we need to find. So this would be A. Okay, this matrix will be called A, and this is X, big X, and this is equal to B. And our goal right now is finding A inverse. Once we find A inverse, we'll multiply with B, and that will give us what X, Y, Z is. And so we're gonna do this by what the book says. Okay, by augmenting with the identity. So I need to do that. So let me copy that down. So I have a copy down here. Let's make sure I didn't write anything wrong. Okay, so 5, 15, 56, minus 4, minus 11, minus 41, minus 1, minus 3, minus 11. And with the identity matrix means going down the diagonal is all 1, everything else is 0. All right, so we need to now do the tedious task of something. Okay, let's see. I will follow what the book says. The first thing we're going to do is take row 1, okay, and we will multiply it by 1/5. That's it. Why? Because we're trying to turn this side to look exactly like that side. To do that, this is a 5. Let's divide it by 5. Okay, that will make it into 1. All right. So to do that, we get this is just row 1. All right, so divide by 5, we get 1, okay, and this divide by 5 is 3. That divide by 5 is some kind of fraction, divide by 5, and then this side is also divided by 5. I forgot. Yeah, everybody has to divide by 5 because the entire row 1 has to be divided by 5, right? Or what? Does it need to be? Yep, that's correct. Yeah, when you do this process, the entire row has to be divided by 5. All right, so that's the first step. Second step, we need to multiply row 1 by 4 and add it to row 2. So we'll multiply this thing by 4, okay, the new row 1. So we'll take row 1 and multiply it by 4, and then add it to row 2. So that's what we're doing right here. So this thing multiplied by 4 added to row 2, that gives this point 0. Next, this multiplied by 4 added to that, 12, that becomes 1. And then this thing multiplied by 4, and wait a second, what am I talking about? This thing, yeah, row 1. This is row 1, the row 1 we're talking about. This thing multiplied by 4 and then added to that. Let's use the calculator for that kind of thing. Okay, so the third item to be, let me turn it on, all right. Well, anyway, so let's see, what am I talking about? Okay, 56 divided by 5, right? Yes. We need to multiply by 4 and then add it to row 2, which is minus 41. So just minus 41. And that equals to something, 19 over 5. Let's write that down. So it's 19 divided by 5. And then continuing, this row 1 has to be multiplied by 4. Okay, this thing has been multiplied by 4 and added to here. So that will be 4/5. 4/5. And because that's just a 0. And next, this thing multiplied by 4, and that's nothing. Then added to row 2, added to that number, and that would be just 1. Okay, and finally, this thing multiplied, added, that's just 0, because they are both 0. All right, so we have come this far. Let me check to make sure that I got it right. So I have 0, 1, 19 over 5, 4 over 5, 1, 0. All right, so that is, so far so good. That's the next step. And the next step we're going to do is add row 1 to row 3. Why? Because row 3 has minus 1. So we add that is the new row 1 will be added to the old row 3. Okay, so the new row 1, which is this thing, this is our new row 1 here. That's the old row 3. So we'll take row 1 and then just add it to row 3 and write down the result right here. And so this thing plus that, right? So these two rows. It's very important to focus on what we're talking about. So that this row 1 will be added to this row 3. I'll write it down here, maybe. So let's do that. These two rows are to be added. So that will be 0, okay? And that is also 0. And then this is, I don't know what that is. Let's pull out the calculator and not have to think too hard. Now, so that we have, what do we have? 56 divided by 5. Yeah, minus 11, right? Minus 11, that equals 1/5. Okay, let's write that down. That is, what did I say it was? Just 1/5. Okay, 1/5. 1/5. And then continuing, the row 1 and 3 has to be added together, so that is 1/5 also. And then these two are 0, and these two are 1. All right, so that is the following step. When we did row 1 plus row 3, so we have now 0, 0, 1/5, 1/5, 0, 1. Okay, so that step is down. And so the next step, we are going to, so we have knocked down these zeros, right? So that's good. We have 0 all the way down here. We need to, next step we are probably doing is we need to kill this 3. Okay, we'll do something with this to get rid of that. So we're going to take this row and multiply it by -3 and add that, and that will kill it. All right, so the next step we are going to do is take, let me draw this thing. We're going to take, what was it? Yeah, row 2. We'll take row 2, okay, times -3 times -3, and then add it to row 1. So that's what we're going to do. So this times -3 added to row 1, that is just, and then write it in row 1, okay? We'll always write it into thing we are adding to. So, and so that is just 1. Next, row 2 times -3 added to that, that gives us 0, which is what we wanted. And then third is row 2, this one, times -3 added to that is, yeah, we'll just use the calculator, okay? I don't want to think too hard. So let's pull out our all-knowing, our powerful calculator. So we have row 2, that's 19 over 5 times -3, and then times -3, and then add it to row 1, okay, which is 56 divided by 5. And that gives us negative 1/5. All right, so I'll write that down. So that have minus 1/5. And continuing, this thing has to be multiplied by 3 and minus 3, okay? Yeah, see, it says minus 3. So 4/5 times minus 3, that is negative 12, plus 1 is negative 11. So that's negative 11 over 5. And then, all right, next, this thing times minus 3, added to that, that becomes minus 3. And then finally, this thing times whatever added, that's still 0. Okay, that is a bit close. They're two different numbers. Okay, yeah. Anyway, so let me check to see if I got it right. Better not have. Okay, so right now we have 1, 0, minus 1/5, minus 11/5, minus 3, 0. So far so good. So the next step, we're going to multiply row 3 by 5. Because the next step we're doing there to turn this number into 1, because we need 1 going down the diagonal. So multiply this thing by 5 will do it. In general, we're allowed to multiply a row and then add it to another row if we choose. So that is the only thing we're allowed to do. So what are we doing again? We need to multiply row 3 by 5, right? All right, so okay, so let's do that. So we're doing all we're doing is multiply row 3 by 5. We'll keep it where it is. Row 3 times 5. So this thing times 5 will have 0, 0, and 1. And then this thing is also 1 and 0 and 5, right? Yeah, okay. So that should be right. And then, but let me check to just be sure. Okay, that looks good. And next, we're going to multiply row 3 by 1/5. What? Oh, yeah. So now that we have a new row 3, we're going to take this thing, multiply by 1/5. Now, I don't have row 2 written down. Maybe I should do that. Yeah, because we're going to do something to row 1 again. Well, row 2 is just this thing, okay? I haven't written it down yet. We'll just, I will skip it. So we'll just, well, if I don't write it down, it means it's the same as the previous row. We just haven't done anything to it. So we need a new matrix. All right, so then we have, let's see, what we'll take row 3 and multiply it by 5 in order to knock this out, right? We'll take row 3, multiply by 5, which divided by 5, which makes it 1/5, and we'll add it to this thing, and then knock that out into 0. That's the goal. All right, so let's do that. Row 3 by 1/5. Let's see. So let's write it down. Actually, let me get rid of some of this stuff. Yeah, okay. So we have a little more space. So we'll have row 3. The new row 3 will multiply it by minus. Didn't we just take row 3 multiplied by 5? So why are we dividing it by 5? Let's see. Well, whatever. Doesn't matter. We'll just do what the book says for now. Okay? So we'll take row 3 multiplied by 1/5 and then add it to row 1. Well, anyway. So row 3 multiplied by 1/5, that will be, this will not change anything because it's 0. So it's the 1 stays, okay? And then this also won't change anything. The 0 stays. And then this multiplied by 1/5 and then added to that is going to be 0. And next, this multiplied by 1/5 and then added to that is Right. That is, that will be, make it 1/5 minus 11/5, that becomes minus 10/5. This times 1/5 and then plus that doesn't change anything. It's still minus 3. And this times 1/5, that's 1. Added to that, that makes it 1. All right, so let me check to make sure that this row is correct. So we have minus 2, minus 3, and 1. Yeah, minus 10/5 is the same as minus 2. I didn't do that, but that's okay. So we have gone to that point. And so right now we have, this is row 1, and this is our row 2, which I haven't written down here. And then this is our new row 3, okay, the newest rows. So let's turn to the next page to see what else we're supposed to do. And so next, maybe I should write it down so that we can see what we're doing. Let's see. We have, the only thing we have right now, we have row 1 is 1, 0, 0 here. Row 3 is 0, 0, 1 here. So the only thing that's left is row 2, which is that thing. Maybe I should write it down. Let me write it down then. So next, now I have the stuff copied down. All I did is fill up this I didn't bother copying before. I copied this line down here, okay? This is identical to that. And then I copied this one from here. And see, they're the same. I just copied it down. So the last step we need to do, we are going to multiply this row, new row 3. We'll multiply the row 3 by multiplied by negative 19/5. Why? Because we need to kill this thing right here. Okay, this needs to become 0. And to do that, we'll take row 3, this one, and multiply by the negative, and then we'll add it to this row 2. And then add it to row 2. Okay, so let's do that. So row 3 multiplied by 19 minus 19/5. So 0 times whatever, and then added here is still 0. Okay, then 0 times whatever, then added the row 2, keeps row 2. And then the third one, 1 times minus 19/5, added to 19/5, that creates the 0. Okay, so we're good here. So next step, but we have to keep going. Row 3, this one times minus 19/5 plus 4/5, that will be minus 15/5. That is minus 3. Okay, and I think I'll just change that. The minus 10/5, I'll just change it to negative 2. There. And so anyway, so next, row 3 times minus 19/5. The next one in row 3 is the 0. Okay, so 0 times whatever, and then added to the row 2, that is stays there. And then finally, this thing times minus 19/5, that's negative 19, and then added to this one, that's still minus 19. Okay, so after all this bother, we're finally done, but that's assuming I got it right. Let's check. Minus 2, minus 3, 1. Minus 3, 1, minus 19, 105. Yes, I got it right. Wow, whoever seen that coming? I'm surprised. I'm as surprised as anybody. But anyway, so this, what have we done? We have created or found the inverse of the original matrix right here, okay? This is the original matrix. We have found that this is the inverse matrix. And we take the inverse matrix and multiply it by B. B is this matrix right here. And that will give us the X. Okay, as we have said a couple pages ago. Where is it? Let me show you. Right here. Okay, to calculate X, we need to find the inverse of the A matrix and multiply it with the B matrix. And all right, so let's do that. Let me write all that stuff down. So I copied it down. Okay, this is A inverse. let's see, I think I'm blocking the camera. Okay, this is A inverse right here, which we found on the other side of the board. And assuming I copied everything down correctly, it looks okay. All right, so then, and this is B, okay? B is just copying down these three numbers in a row like this. Now we need to multiply them together, and that will give us X. What's X? X is the value of X, Y, and Z. So let's do that, but I need some space. Okay, so I wrote some space there. So this A inverse, which is this thing, I forgot to write down the inverse here. A inverse, okay, times B is going to be equal to X according to the formula. What's X? X, the big X is the XYZ matrix. And each one, the number that we find out will be corresponding to the variables. So let's do that. And we're going to do the matrix multiplication, which is the row times column. Okay, you always take these things and then turn it and multiply by this. So we'll have negative 2 times 35 plus minus 3 times negative 26 plus 1 times negative 7. So you take the row and line it up on the bottom and multiply each one correspondingly. Let's see. All right, so let's do that. We have I think if I hold it this way, my calculator might be blocking the view. So we'll do it maybe on this side. Is that better? Yeah, I guess a little bit better. So that's what I'm going to be doing. I'll turn on my calculator. There. So we'll have minus 2, negative 2 times 35, and then minus 3 times negative 26, and then plus 1 times, 1 times negative 7. Okay, so that should be the first number, which turns out to be 1. Great. All right, so let's say it's 1. And that means, what that means is X equals to 1 in this pile of stuff, okay? And so the next thing, I'll take minus 3 times 35 plus 1 times 26 plus minus 19 times negative 7. So let's do that. Negative 3 minus 3 times 35, and then plus 1 times negative 26, and then plus negative 19 times negative 7. Well, yeah. And that's about it. So let's push enter, and that equals to 2. All right. So after all that mess, we got 2. That means y should be equal to 2. And finally, the third row, okay, times the third column. 1 times 35. So we'll have 1 times 35. 0 times the minus 26, so we'll skip that. And then minus 5 times 7. That's 35. That is equal to 0. So the third number is 0, and that is the value for z. So that should be that is the answer matrix. That is x equal to 1, y equal to 2, and z equal to 0. Okay, so that's great. But let me check to make sure I got it right. Where's my book? Here it is. Okay, so that what is this anyway? Example 8. It has 1, 2, 0. Yes, we got through all this. I don't think I made a single mistake out of this giant mess. Okay, so that is the answer to example 8. Now, what your book did is your book wants you to multiply the original A with the inverse of A to make sure that it turns into an identity. And to do that will help you be sure that you didn't make a mistake. But I skipped that part because let's not work that hard. because assuming that our inverse is correct, okay, then you just multiply by b and you get the answer. To multiply the A inverse with A is just a checking step to make sure, because if A inverse and A multiplied together doesn't become the identity matrix like this, then you know somewhere you messed up. But anyway, so that is example 8. Now let me erase the board. Actually, I'm tired after doing this much work. This is so hard on me, but at least I got it right, so that is something to be proud of. Okay, so I will finish this section in the next video.